Okay, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. Now we are going to discuss chapter 2, integration. In this chapter, we will cover three sub-chapters. The first one, in 2.1, we will discuss integration of function. Next, we will continue on 2.2, technique of integration. And lastly, we will cover 2.3, definite integrals. Okay, this is the first thing that you all should know, the definition of integration. Integration is the reverse of differentiation, or sometimes we can call it as an antiderivative. So the keyword is reverse of differentiation.
If dy dx is equal to f prime x, then
Y is equal to the integration of f prime x dx. So this is example 1. Show that d dx
bracket x squared times exponent x
is equal to x exponent x bracket x plus 2. Hence, find A, the integration of x exponent x bracket x plus 2 dx. Part B, the integration of 2x exponent x bracket x plus 2 dx. Part C, the integration of 1 over 4x exponent x bracket x plus 2 dx. So for the first question, we have to show that when we differentiate x squared exponent x, we will get x exponent x bracket x plus 2. So first, we will let our y is equal to x squared exponent x. From our previous semester, during our semester 1, we know that in this case, we will apply product rule. So this is the product between x squared times exponent x, where we try to assume that our x squared here is our u, where our exponent x here is our v. Next, by using correct formula of product rule, we're going to have x squared exponent x plus 2x exponent x. Okay, where our x squared is u and exponent x is v prime. When we differentiate v exponent x, we're going to have exponent x. Next, our exponent x here is v, and then 2x here is a u prime. Okay, when we apply the product rule here, u v prime plus v u prime. Then, after we try to factorize x exponent x, we're going to have x exponent x bracket x plus 2. So we already showing. Okay, for part A here, if we are trying to integrate x exponent x bracket x plus 2 dx, we're going to have x squared exponent x plus c. By going back to the definition of integration, which is antiderivative, or we call it as the reverse of differentiation. Still remember, when we differentiate x squared exponent x, we're going to have x exponent x bracket x plus 2. So that's why when we integrate x exponent x bracket x plus 2, we will have x squared exponent x. But please don't forget to put plus c. Next, for part B here, the difference between question part B and part A here is coefficient of 2 here. So we may factorize or put 2 outside the symbol of integral here. So it can be written as 2 times the integration of x exponent x bracket x plus 2. Since we already have this solution or answer previously, we may write our final answer as 2x squared ex plus c. For part C here, it is the integration of quarter x times exponent x bracket x plus 2 dx. So still remember, so for 1 over 4 here, you may factorize like previous one, part B, before this. And you're going to have a quarter times the integration of x exponent x bracket x plus 2 dx. So this is our previous question for part A. Next, so the final answer should be 1 over 4 x squared exponent x plus c. Don't forget to put or to write plus c for every case. Next, the basic rules of integration are, okay, the first one, when we integrate dx, we have x plus c. So the example is the integration of 2 dx. Next, when we integrate x to power of n dx, we're going to have x to power of n plus 1 over n plus 1 plus c. And we have to make sure that n must be not equal to -1. So the keywords here for every power here, n, you have to plus 1 and then divided by n plus 1 on denominator side. So this is simple example, the integration of x to the power of 5 dx. Next, the integration of k fx dx is equal to k, the integration of fx dx. So in this case, fx is a function and k here is a constant. So you may factorize k in this case. Example here is the integration of 3x squared dx. Next, the integration of bracket fx plus or minus gx dx. In this case, there are two functions, which are fx and gx. And the operation here, either subtraction or addition. Okay, next. Okay, this is the example. The integration of 3x squared plus 6x dx. For our previous example, the integration of 2 dx here should be 2 dx is equal to 2x plus c. Next, for the integration of x to the power of 5 dx, you're going to have, okay, x 5 plus 1 over 5 plus 1 plus c. And simplify, it will be x to the power of 6 over 6 plus c. Next, the integration of 3x squared dx. So first we have to factorize 3, the integral of x squared dx. Next, it's supposedly equal to 3 bracket, okay, x squared here, we have to integrate power of 2 here, and then it will be x, 2 plus 1 should be 3 over 3 plus c. Okay, next, the integration of 3x squared plus 6x dx here, it is equal to the integration of 3x squared dx plus the integration of 6x dx, and it is equal to 3x cubed over 3 plus 6x squared over 2 plus c, and simplify, we're going to have x cubed plus 3x squared plus c. Okay, be cautious. So for this case, the integration of fx dx is not equal to the integration of fx dx times the integration of gx dx, and the integration of fx dx also not equal to fx, the function of fx, times the integration of gx dx. And lastly, the integration of fx over gx dx is not equal to the integration of fx dx over the integration of gx dx. Please make sure don't do like this. Next example, example 2. For part A here, the integration of a dx. So here you're going to have ax plus c. Next, for part B here, when you integrate this one, you're going to have, okay, 3, the integral of x dx. Next, you're going to have 3x to the power of 1 here. Then 1 plus 1, 2 over 2 plus c. So you may write as a 3 over 2 x squared plus c. Next, for part C here, when you integrate 1 over x cubed dx, first, we try to simplify 1 over x cubed first. So it will be equal to the integral of, okay, from denominator side here, okay, we bring to numerator side. So it will be x to the power of negative 3 dx. And then we integrate x to the power of negative 3 here, and it should be x negative 3 plus 1 should be negative 2 over negative 2 plus c. Okay, or maybe you may write as a 1 over negative 2 x squared plus c. Both correct. Okay, next, for part D here, when we integrate square root of x dx here, first simplify as the integral of x to the power of half dx. Next, it will be x half here plus 1 over half plus 1 plus c. Okay, next, you're going to have half plus 1 should be 3 over 2 over 3 over 2 plus c. Okay, next, when you simplify, you're going to have 2x to the power of 3 over 2 over 3 plus c. Next, for part E here, when we integrate x cubed plus 2x plus 1 dx, it is equal to, okay, we integrate first term, second term, and third term here. So here will be x to the power of 3 plus 1 over 3 plus 1 plus, okay, our second terms here, 2 x to the power of 1, 1 plus 1 over 1 plus 1 plus, okay, next, 1 here, you integrate, it will be x. And lastly, plus c. Okay, next here, when we simplify it, our first term here will be x to the power of 4 over 4 plus, okay, 2. Okay, the denominator side also 2 here. So it will be x square plus x plus c. So this is our final answer. Next, so for f here, this is your homework. I hope you all can do this question for part F. Next, the integration of ax plus b bracket to power of n. So when we integrate ax plus b bracket to power of n dx, it must be equal to, first, for ax plus b here and to power of n here, okay, we need to plus 1, the power, and then n plus 1 here, we have to put on the denominator side, and then ax plus b, which is a linear function here, we have to divide only the coefficient of x here, which is a. Put a, then plus c, and n is not equal to -1. So this is simple example. When we integrate 3x plus 2 bracket to power of 3 dx, okay, it is equal to, first, 3x plus 2 bracket to power of 3, 3 here plus 1 should be 4, and then here is a 3 plus 1 also 4, and then a here is 3, and then put 3 here, and then our final answer should be 3 times 4 here on denominator side should be 12. So this is our final answer. Next, find, for part A here, 1 plus x bracket to power of 6. When we integrate this one, it must be equal to 1 plus x bracket 6 plus 1 over 6 plus 1, and then coefficient of x here is 1 plus c. So here will be 1 plus x bracket to power of 6 plus 1, 7. 7 times 1 also 7 plus c. Simple. Next, for part B here, it is equal to, okay, 1 plus 2x bracket to power of 6 plus 1 over bracket 6 plus 1, and then our coefficient of a here is 2. So that's why we have to multiply by 2, and then plus c. So final answer here should be bracket 1 plus 2x bracket to power of 7 over 7 times 2 will be equal to 14 plus c. So this is our final answer. Next, when we integrate bracket 1 minus x to power of 6 here, we're going to have, first, bracket 1 minus x bracket to power of 6 plus 1 over bracket 6 plus 1, and then a in this linear inside this bracket is -1 plus c. So here you're going to have bracket 1 minus x, 6 plus 1 is 7, and then 6 plus 1, 7 times -1, -7 plus c. Next, for part D here, okay, this is equal to 1 minus 2x bracket to power of 6 plus 1, 7 over 7, and then the coefficient of x here is a -2 plus c. So final answer should be bracket 1 minus 2x bracket to power of 7 over -14 plus C. When we integrate square root of x plus 2 dx here, first we have to simplify it as the integration of bracket x plus 2 bracket to power of half dx. Next, it's gonna be bracket x plus 2 bracket to power of half plus 1 over bracket half plus 1, and then differentiate x plus 2 inside this bracket will be 1 plus c. So the final answer should be 2 bracket x plus 2 bracket to power of half plus 1, 3 over 2 over 3 plus c. Next. Okay, for part F here, this is your homework. Please find the answer.